I want to share with you guys is that for the team we really have a very strong product R&D ability. So because of their strong background in the technical field, so basically each pieces of product was developed by the team is a masterpiece, including the hybrid model from 3 to 6 kilowatt, the SNA unit from 5 kilowatt to 6 kilowatt. Also, even the model that is targeting to the US market. I mean the split phase. So also the AC couple model. All of these products are warmly welcome after we launch them into the market because of their high quality and their good performance. So yes, Enrico know perfectly about product because of the good quality and also the high the good performance. We quickly have our own position in the South Africa market and also in other countries like Philippines or Vietnam or even Jordan, Lebanon, and UK and Germany and so on. And this is yes, I just want to talk something about the product so that we can know something about the team. And the third point I want to share with every one of you is that LUXPOWER is basically an R&D oriented company. Right now we have about 120 employee in the company, and 60% of them are engineer. And so you can see the rest of staff only occupy a very low percentage in the total number of employees. So we are focusing on developing develop the product and then improve in excellent quality, and then try to build up the brand all around the world. So so this is a brief introduction of the company. Yes, of course, we started to cooperate with NASDAQ since the beginning of 2022, and so today we are holding such a training program for our partner. And with an aim to share technical information to everyone, including our sales rep, also our sales engineer, so that we can know more about the product. It will enhance our sales outcome. So, I think that's all. That is what I want to talk about LUXPOWER. And then next, I would refer to shift to Enrico, and then he is our partner in South Africa, and yes, he is really so he is an expertise of our product, very well about our product. And yes, so Enrico, then you can start the training and yes,
thank you.
Continue the training program. Yeah.
Thank you, Elix. Thank you very much. Good morning, good day, everybody. I'm Enrico Andrews. I'm located in Cape Town. I work from Aspergo Energy. They are distributors and as well help with technical support and a repair agency for LUXPOWER. We supply our product around in and out of the Western Cape. I know many of you are not from this country, but in our country we experience something called load shedding, where our municipality during time to time during the day cuts our power. So now we actually at our branch, and this is one of the machines that we use during the backup when we do experience load shedding. So from time to time, we will also swap this machine with clients' machines just to do the testings. I've worked now with at LUXPOWER for the last 6 months. Um, I began doing repairs and then moved to the technical support. I as well, I'm done my mechatronics engineering here at our institutions, and I'm busy now as well getting my wireman's license to as well help in the field with clients on-site support. But let me go into the presentation, which we've all been waiting for. Okay. Okay. So today's presentation is all about the SNA 5 kilowatt hybrid inverter. This is one of the inverter models that we have at LUXPOWER. This is the one of the most cost effective, especially for importing. It goes as low as a 3 kilowatt, but for the main interest today being the 5 kilowatt. Why LUXPOWER? So our LUXPOWER brand is partnered with the Heino ESS company, which does the batteries. Here is our range. Coming soon in the new year, we will have a upgrade on the SNA 5 kilowatt. So today's information will also be very helpful for when the introduction of the newer upgraded version arrives. Then we also have the LXP 5 kilowatt, LXP 10 kilowatt, and 12 kilowatt. Each one of these models are parallelable, but not with one another. You may only parallel SNA 5 kilowatts with SNA 5 kilowatts, LXP 10 kilowatts with LXP 10 kilowatts, and so forth. When connecting or pairing our LUXPOWER inverters with the high-NOR batteries, the Power Gem or the i5, you do get extension on the warranty. As well, be sure that you need to register the warranty online. Why Lux technical support? We have a multi-channel technical support. We have our local support centers in Joburg, Durban, Cape Town. But with this regards, we are very international, so we do support international clients in Africa, or the most of Africa, in Namibia, in Congo, in Nigeria. We soon going to provide support for USA in the future, and as well the European countries and Saudi Arabia. This is the contact number for the technical support, 060-355-4562. I think through Moses, I'm going to send Moses the links to the WhatsApp groups. There are more technicians in the WhatsApp groups with experience on site. That also helps other clients with issues. So if there's one person that's unavailable at that moment, there will be other people in the group that will be more than willing to help. Today's contents of the presentation is the features of the SNA 5 kilowatt, specifications, the interface introduction, general wiring diagram, working modes, parallel solutions, generator remote control. Okay, Our 5 kilowatt SNA is a multifunctional high frequency pure sine wave off-grid solar inverter. Here's an example of two installations. This is a parallel installation of two SNA 5 kilowatt inverters with two power gems. So as you can see from first inspection, that each inverter has its own battery disconnector, meaning that each battery is connected to its own inverter. I can't necessarily see that these two are in parallel, but you can have them splitted onto sectioning your house. So you can section your house with one inverter providing power 5 kilowatts to one section, and then on another section, the other 5 kilowatts. Here's another example of paralleling the 5 kilowatt inverter. You can do a 3-phase paralleling. So the first inverter can be this is the master inverter. The second is the sub inverter, third, second sub, and the fourth is the third sub. Different installations are done differently. These are your PV photovoltaic protection boxes, and these are your battery protection boxes. These are just two examples of the manner which you can do the installations with our SNA 5 kilowatts. So the total output power on this one end will be 10 kilowatts, and the side will be 20 kilowatts, and your energy per hour, 10 kilowatt energy hour. The side, I think, here's about 6 batteries, each being 100 amp hour. So that's about 600 amp hours available to the client. This inverter is applicable for pure off-grid, power backup, and self-consumption, meaning PV and AC takes loads jointly. The rated power is 5 kilowatt. The inverter has two dual MTTP solar charge controllers. When you look at the manual, you will notice that it says SNA 5000 WPV. That means wide photovoltaic voltage. So we have a very wide photovoltaic voltage ranging from 120 volts to 480 volts DC. The max input current 13. On per string, there is a maximum kVA of 3.2, and on together the total wattage is 6.4. The inverter is able to run with or without the battery in on-grid and off-grid mode. There is a feature I will show you further on the web page where to activate the PV off-grid mode with the inverter, as well as a separate generator interface able to control a generator remotely. Here on the side, you will see is an example of the inverter and its performance data when connected to a power gem. So as the solar and utility grid can loads can take the loads jointly. PV and AC can take loads jointly. And in the settings, you can set it regarding the times in which you want to introduce the grid, and as well the times which you want to charge the battery. You can parallel up to 16 inverters, 5 kilowatt SNAs with one another. The inverter supports CAN RS485 for lithium battery, BMS communication. It's a multi-battery compatibility. Wi-Fi, GPRS, remote monitoring, setting and firmware update. So we have website support and free iOS and Android app. Actually, in fact, just yesterday was the new update released for the ISO Apple for monitoring on your Apple devices. Here is a page that this is how we usually set the inverter with according to the time slots. So we'll start at the 00 time slot and it will go up to 2400 hours. So this relates to the clock in the day. Here as well on the side, our inverter can go completely off grid. In this inverter is the quality of the inverter is great, and the capability of being off grid is remarkable. So here you can see with the newer version coming in the future, the SNA 6 kilowatt, you will be able to pair the LXP CT clamp. Now with the LXP CT clamp, you measure the direction of the grid flow to the inverter. So this LXP CT clamp is used in the exporting to grid. So the SNA as well also has the exporting to grid feature. To enable the exporting to grid feature, you need the LXP CT clamp. Now, the reason why it's an LXP CT clamp is because this clamp is shipped standard with the LXP models of our inverter. With the LXP models of our inverter, those inverters, the LXP range has a higher IP rating. So when working with the LXP, it's a complete off-grid inverter, and you are capable of installing that particular inverter outdoors. So that's the reasons why the difference in the costing of the two inverters. This one is for indoor installation, and our LXP will be for outdoor installation. Yes. So these are the features. We will continue to go through all the features in the presentation. The first step in doing the installation of an SNA is setting up an account. So you need to set up an account. Firstly, you need to create an end user and a station. The end user and the station should be binded together when creating the account. And you sorry guys, I'm moving a bit too fast, I think. Let me just get my bearings. If you are, for example, Nastic is a distributor and a wholesaler of LUXPOWER. So we have our server admin at the top. That is our main technical support. That is a contact that any of you can contact at any time. We will the main supports the distributor, the installer, and the end user through our channels. For many of you, you are probably installers of Nastic. Therefore, it's important that each of the installers have their own installer account. So with each installer account, there's a specific customer code, and that specific customer code is used at each of the end users installations. So this specific installer will have to input his customer code to this client and that client, but keeping in mind the installer that purchases from the distributor has its own code that he gives to the installer, and this specific installer as well has to have a specific installer account. So the distributor's account can see the installers and can see the end users of these installers. But for installers to help the end users much better, it's preferred that they have their own accounts with their own customer codes that they give to the end users. Here on the side is a picture of a screenshots of what an installer account will look like. Inside the installer account, you will have, here is 5 end users, 6 end users that belongs to this specific installer. So the installer is able to see his installations, and then the distributor is able to see all the installers that he supplies to and their installations. Getting back to creating an account. So going through the process of having the proper account, installers has to inquire from the distributor, and the distributor has to inquire from LUXPOWER for the appropriate accounts, and each account has its own customer code linked to that profile. Here's the installer account example screenshot, and then this is the, once you've loaded the app, this is a screenshot of what that app will look like on first inspection. This is what you'll see on the app. Firstly, you would have to register and create a client for a customer, account for your end user. Here at the bottom is the customer code, distributor or installer code. So this is what I was meaning. If you are installer and you create your first account, you put in your distributor's customer code. And if you are installer creating an end user account, you put in your customer code as an installer, and all the installations will appear like this. Okay. When connecting the dongle to the Wi-Fi, so we haven't, so we've went through the features, and now we are setting up an account before we either you have mounted the inverters already or you haven't, but this is a step that can be done, that should be looked at in the beginning, especially for installer, before going to the site, that he has the correct customer codes to give the client, and also to know he can do this before any inverter is up on the wall. He can already start creating an account and a station setup for his client. Now going to the dongle, setting up the dongle is not a long process. It's about a 10-minute process. The way you set up the dongle, you have to first download the app onto your phone. Once you've downloaded the app onto your phone, you scroll down on your main title, your main menu bar here on top, you scroll it down, you go into your Wi-Fi settings, and you search for the dongle's BA number. Search for the dongle's BA number. If you can see me on screen at the moment, see there's a BA number and the pin. You search the dongles, you scroll this down and you search the dongle's BA number in your Wi-Fi list. You connect to that BA number. Your cell phone will ask you whether you want to keep that connection or not, because there's no internet that comes from the dongle. You say, yes, I would like to keep that connection. Once you've done that step, you go then onto the app. You will go onto the app. You will come to the first page of the app. And at this point, you do not need to log into the account when connecting the dongle. You go to dongle connect, and then it will bring you to this page. So once you're on dongle connect, you're in this page, then you have to search your Wi-Fi router SSID. You can type this in manually. If you can type it in correctly, you can input this manually, and then you have to input the password, and thereafter connect to home Wi-Fi. It will then tell you that connection is successful. You just have to wait a minute or two, and your dongle will boot up. You will get this pattern of lights that starts flashing. So it will start with the Wi-Fi LED flashing, cloud icon, and then inverter LED icon. So you need to have all three lights solid for you to see it online, giving you a normal online status like this. Once you have the three lights, you you will be online with a normal status, and then you will be able to view and remotely set up and update that particular inverter. Also, it's important, yeah, for you to set up your inverter to have all three lights green. Specifications of the SNA 5 kilowatt. So the SNA 5 kilowatt this is new specifications. So there's new specifications. There is two versions of the SNA 5 kilowatt. There is the older version with the red dip switches and a newer version with the blue dip switches. But this version, this is the data that's on the website at the moment. It's more closely spec'd to the SNA 6 kilowatt that we're looking forward to getting in future. But the main specs still remain the same. I mentioned this is actually this is supposed to be 3.2 with a new inverter. I think the inverters being shipped in this year will have the specifications. So the maximum PV array power that you can put onto the inverter is 8 kilowatts. It's a dual MPPT. Each MPPT takes 4 kilowatts of solar that the inverter uses. So now you're probably asking a question, what happens to the other 3 kilowatts of power? So if the inverter has over 5 kilowatts of power that it's getting into the machine, the remainder of the power goes to charging the battery. So in the end, the inverter's maximum charging and discharging remains 5 kilowatt, and the excess power that there is on the inverter goes to the batteries for charging. The rated PV input voltage is 320. There's a dual MPPT. It's a wide photovoltaic input range from 100 to 480 volts. This is, of course, the DC voltage that's coming from the panels. This is the MPPT range. It's a slightly narrower range. The startup voltage for the PV, the solar panels, is 100 volts. So it's important also to make sure that you design the PV or the solar panel according to the startup voltage of the inverter, because some of the panels has about 32 volts, and when you have about 3 panels at 33 volts or 32 volts, you like 3 or 5 volts short of the 100, and the inverter will see the voltage on the MPPT, but will not be able to use it until it reaches the startup voltage of 100. The max solar panel PV input current will be 17. At the moment, it's 13. The the max PV short circuit current input per MPPT is 25. The SNA is compatible with lithium ion and lead acid. Rated battery input voltage that it can take is 48 volts. It has a battery voltage of 38 to 60 volts. The maximum charging is 110 amps. This amperage, this 110 amps is related to the 60 volt DC. So the power that we get in the end is 5 kilowatt. So when you do your power formula, you would want to keep when setting your inverter for battery charging and discharging, you don't want to lose the lifespan of the battery very fast. And you also don't want to burn out any components inside the inverter. So the power formula is power equals voltage times amps. In this case, for the battery, it's a DC voltage and a DC amps that will give you up to the 5 kilowatt maximum charging and discharging. On the grid side, we have a voltage in the AC, 230 volts in this particular country. It's 230 volts. Frequency 50 and 60 hertz that can be set online. The AC output of the inverter is 22 amps, and the max wattage of the inverter is, of course, 5 kilowatts AC output. These two as well, the 230 multiplied by the 20 amps here will give you the 5 kilowatt output. The maximum AC input is also 8 kilowatt. So the voltage coming in from your grid can go up to 8 kilowatt. The solar panels that you have on the roof coming in per MPPT is 4 kilowatt each. Total that can be up to between 6 and 8 kilowatts on the roof. And then of course your battery that has a range of 38 to 60 volts. This is the IP rating of the inverter. This is the general dimensions, the weight of the inverter. The UPS range, uninterrupted supply range, is similar to the AC range that we have, 5 kilowatts. The max amps is 22. These inverters can be parallel, and when paralleling or having them as standalone units, on the web page, there is a AC input range. So it's be very careful to make sure that you have the inverter with the correct input range for the switching within on the main board. It improves the efficiency of the switching and giving you, of course, a more pure waveform. These standards here at the bottom and certifications are related to the various countries and the standards that they need to follow. Installation requirements for the SNA 5 kilowatts. The SNA 5 kilowatt on the AC side, you need to have a 25 amp input breaker or lower, between 20 and 25. For the output breaker as well, you need a between 20 and 25. This range is given, but the correct one would be 20. The reason why we say 25, because you end up losing the 2 amps. You end up losing 2 amps. But for the safety of the device, you will want to stick to the 20 amps So the output of the unit will be 20 amps times the 230. So it will be up to 4 point. With a 20 amp breaker, you will get up to 4.6 kilowatts of power from the unit. But because of standards, you don't usually find a 22 amp breaker. So therefore, we give you the two recommendations of a 20 and a 25 amp. On the AC protection side, you also need your earth leakage for any fault current that may occur. Surge protection device of 275 volts. You need your indicator lights for your grid and your indicator lights for your change inverter. On the AC side, you also need the changeover switch. This is required to bypass the inverter in case of faults and needing to take the inverter off for inspection and repair. On the DC side, the strings must have positive and negative fuses. The DC side, strings positive and negative. This is the solar panels with a PV range of 100 volts to 385 volts. Here's the 13 amp MPPT. The S surge protection device that you put on the DC side of the solar panels is a 500 volt. Should be, this is according to standard, because the range or the maximum voltage that the machine can take is about 480 volt. A battery isolator is required and a battery disconnect neck box. I'm just going to take you back to the first two pictures where there's a proper installation with this list of requirements that are there. Here they are. So all those protection boxes. This is your solar panel protection boxes, and these are your DC panel protection boxes. Your changeover switches. Your changeover switch is here on the side. Here you can see within this protection box, we have our indicator for ESCOM, that ESCOM is present or the grid is present. And as well, we have an indicator light that the inverters are working and functional. So this is your AC protection box. In there will be also your changeover switch to bypass the inverter in times of firmware updates. As when doing the firmware update, the inverter switches off, or you need to take it in for repairs, as I mentioned. So these are the protection boxes for your installation requirements. PV input design. So this is this is a important step, especially for clients that's completely off grid. They, of course, typically going to take solar panels with the inverter to recharge the battery and supply power to the loads that they have. There's many methods in connecting your solar panels. You can choose a variety of methods to connecting your solar panels. Connecting it in series, your volts add up and your amps stay the same. Connecting it in parallel, your obviously your volts stays the same and your amps add up. The maximum VOC for the SNA is 480 volts. So you take your number of panels, this is 1, 2, 3, 4, times it by your open circuit voltage per panel. Each panel here is 38 volts. So we add those 38 volts, it gives us a 152 volts open circuit voltage at 8 amps. So this is a good way, good method in connecting panels, keeping the voltage at a high voltage and a low amperage. So using a combination of this two, you can play around with a configuration, and you can optimize it as much as what you would like it to be, or according to your customer's needs. Interface. The introduction to the interface of the SNA, we have, if you can see behind me, there's an SNA. I'm going to take you through the SNA behind me shortly. I think, yes, I'll take you through the SNA behind me now. The interface, you have your general, here you can see your general area. Over here, you have your general work area, LCD display. You have the enter is your function button. This is your fault warning status indicator. This is your normal status indicator. This is your up down to toggle through your menu on your LCD display. When you open up this cover, you are allowed to open up this cover. Firstly, you are allowed to open up this cover, which is here on top, to do your connection. In front of at the bottom side here, here's grommets, where you insert your cabling to fasten them to your terminals. So here at the bottom, you insert through the grommets your cabling, fastening them to your terminals. You will have typically for the battery cabling is 25 mil. Using the lug to fasten it on there. For the PV or the solar panels, there's a specific solar cabling that you have to have according to standards that you would wire up from the wiring to your panel terminals usually comes from your protection box. The AC input will come from your changeover switch, and then your AC output will go to a circuit breaker, an output breaker of around about 20 or 25 amps, depending on the recommendation is between 20 and 25. I would put a 20 amp because the maximum is 22 on the output side. So between the load and the machine, there should be a breaker as well. At the bottom, what you're going to find is the on and off switch. On the far right-hand side is your on and off switch. Your grommets here, your EPS on, off switch, your lithium ion. This is your communication, your Wi-Fi for your dongle. This is RS485 cable for your battery. And these two terminals at the bottom is your parallel communication ports. Please also keep in mind when doing the parallel communication, resistor switches need to be up. This resistor dip switch coloring on the plastic of this is either red or blue. The red being the older version, the blue being the newer version. This is the dry port contact for your generator input. The generator will then, when you connect your generator to the machine, the application of the generator to the machine is mainly to charge the batteries. So you will use the power from the battery to supply your load. And once your battery reached a certain SOC, the generator kicks in and then puts back the energy into the battery. So the generator does not actually do the load performance. So with load performance, the inverter and the battery takes care of the load performance. But as soon as the battery gets to a certain level on the SNA, the generator supplies power back to the battery, like a solar panel would when you're using a solar panel on this inverter. Working modes. Sorry. Interface introduction still. This is your general work area. On your inverter, you will see a general hopefully you can see. On top will be your time. Over here is your time. The second area is your first area will indicate the general information display area. The second area is your on-grid, this LCD display, so it will just give you an overview of all the performance values and load values of the specific setup. Here at the bottom in area 4, you will get your normal warning and your fault indicator. The inverter will tell you exactly what type of setup you have. You just have to look at your normal and your code that you get here in the corner. That code will tell you what type of setup you are running and whether and if the inverter is happy with that setup. This is very important for clients that's completely off grid. So if you're doing this particular person doesn't have internet available, you're going to usually set up the inverter manually. All the shipped is with the inverter in the user manual. All of it is in the user manual. There's what it means in the user manual. This is just a general brief description. Very important with solar panels is to set it up on the inverter and make sure the inverter knows before connecting the solar panels, because this can short out the MPPT board on the inverter. This can short it out inverter. So first tip and trick is to, when you're completely off grid, no internet, you'd go onto the inverter, you would give it battery power. Firstly, you need to power up the inverter. So you put the battery on the inverter, you put the battery power on the inverter. Once there's battery power on the inverter, you hold in enter. You'll get the spanner icon in the corner. You would see there's a spanner icon, and you will start toggling between all those settings. So the first setting that we'll look at is the first setting, the time and date. Making sure that your time and date is correct. The next setting is your solar panel setting. You'll go down to number 2, go up to number 2, and this area will flash. This area will flash on the inverter. It will flash on the inverter that you are busy now with this area, and then you would tell the inverter that you have either one string coming from the solar panels, or you have 2 strings, or you on top of your roof you have 1 string, that, and you will make use of both MPPTs. You will make use of both MPPTs. Your battery. Next, you'll go up to your battery, set up your battery. There is a battery compatibility list that you need to double check. There's some batteries that's on the market that has a great BMS. There's a lot of lithium ion batteries on the market that has great BMSs, but not all of the batteries are compatible with LUXPOWER. So there is a way that we have this list. So there's many tests done in the lab. So we don't if we find, like, for example, S-Volt is an example of a battery that can work on the lithium ion settings or the lithium ion protocol of the machine, but sometimes there will occur issues, and the engineers from China will immediately say that there is a compatibility list, and those other battery brands, because or one or a few of them are working, doesn't necessarily mean we're going to have them on our compatibility list. So if you do not have a battery that's under the lithium ion batteries, you go enter, you in the battery settings, and then in the battery settings, you will toggle between lead acid or lithium ion. So you'll choose lead acid if it's a non-compatible battery. If you're using gel batteries, or the gel batteries are usually 12-volt batteries, and you need to have 4 of those batteries in series to get 48 volts. That's an example of batteries also that you would directly put on lead acid. There's obviously not a BMS that's compatible with the inverter. The rest is also other settings that you will find the definitions of in your user manual. Here is the status codes of the inverter. The normal happy smiley face. Each code will tell you exactly what is being set up. So this status codes is very good. It's good information. It tells you that your inverter is happy and it's aware of all the inputs and outputs that that the inverter is supplying and getting power from. Error codes. These fault codes, you have to contact many of the fault codes. I know there's plenty of engineers in the group at the moment, and at with a warranty. So I don't know the complete understanding that you guys have with LUXPOWER. You probably have to still ship the inverter to a certified agent. I think Nastec is a repair center as well, and for example, the internal communication fault 2. This is a very common fault code 17. Why I say it's a common fault? It's because especially the customers using solar panels. So there could be the bus voltage is over 500 volts. That means that the solar panels, during its conversion to AC, broke a certain component inside on the main board, and this is a fault that requires further inspection from a repair agent. Some of these faults can be cleared with updates, and some of these faults are cleared. For example, phase error in a 3-phase parallel system. This error can be cleared with the use of CT clamps, also ensuring that your phase rotation of each phase in the three-phase system, and making sure that that the red, white, and blue phases are separated properly. Here's a hand raised. Um, you're welcome to ask the question, Petrus.
Yes, Enrico, Petrus, Pupkewis Megatech, Namibia.
Yes, sir.
Okay, so you have spoke about fault number 17, because I have actually met that quite before, but I would just want you to you didn't actually explain what is really causing that.
Okay, I'm going to give you an explanation. So that's the question. I'm going to give you a deeper explanation now. Because in the end of the that's one of the issues that's you're not able to fix on site unless you have main boards, and you need to get main boards from the repair agent. So the internal fault 2 is the bus voltage is higher than 150 volts, and the MPPT and SPS is working together, but the comms board fails to receive communication data. And the data that it receives is abnormal data for 5 seconds. The way to clear this fault is that the board needs to receive normal data with a time range of 2 seconds. So the data that it's receiving is delayed due to the damage on the board, and the data that it needs to be received within 2 seconds. So this is one of those faults that you need to take down your inverter, and this I can tell you specifically, this is a main board needs to be replaced. So there is probably a main board. Just give me 1 second. I'm going to show you on the camera when the MOSFETs are overworked, then the MOSFETs will actually blow on the board. They blow, and this creates that fault. Just give me 1 second. I'm now back in front of the screen. I don't know if you can see from there. See, this particular MOS is completely blown off the board. So this is how the main board looks for interest sake.
Yes, we can see, but that error 17, I actually seen it on it was the MPPT, and I have 2 MPPT that got banned just at the same spot. That's why I'm asking, because I would like to know if it's a manufacturing error or what, because I have 2 boards that are just banned at the same spot.
Yes, so that can also happen if in the beginning you did not program the inverter to take up the solar panels. That can happen as well. Okay, Petrus, I'm going to also answer more questions at the end of the presentation for you.
Okay, no problem.
There are more warning errors, more warning codes. Battery voltage high. Ensure that the battery voltage is within the range of the inverter. Battery voltage low. This obviously you need to make sure that the battery voltage is higher than 40 volts. Battery open. Once your battery is open, that means the battery is much lower than 40 volts, and you need to get the battery charged up again. EPS overload. So these are warnings. The machine warning you before, say for example, the battery swells the cells. swell inside of the battery, or your battery gets open. Yeah, so these warnings are great. The end user can get notifications as well from the inverter. EPS overload. This just means that you probably need to switch off certain items. And yes, fans, warning number 9, fans stuck. This is another fault where you have fans stuck. There might be a piece of something that's stuck inside the fan, or sometimes the fan itself has gone faulty and the fan needs to be replaced. Battery communication error. The battery failure, communication failure with battery is also another warning. In this case, when checking the battery failure, communicating to fail can usually mean that the 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 battery's comms cable is not correct. Yeah, I got a cable tester. So for the batteries, I'm still getting to the compatibility list. I have a cable here. So when creating the cables as well, please make sure that you use the cable tester to make sure that the connections is correct and that you have the right cable. The general wiring of inside the inverter. These are our relays for remote control. These are our remote control relays. This is the battery switch, the main isolator for the batteries. This is your solar panels, up to 480 volts. Yeah, this is just your general overview of the relay switches within the inverter that is programmable through the web page in terms of normally open or normally closed. So these relays can be set according to the max output, or also the time slots in which you want to use the grid, or the time slots in which you allow the battery to charge and discharge. Battery communication. Here's the battery compatibility list. And here's the battery compatibility list, as you can see at the bottom. Here's the communication CAN cables. Pylon Tech is on number 2. Hyna is on number 6. Dynas is on number 8. You need to make sure that the cable is correct. So you just do your cable test. This is a normal straight cable. You will go through checking each cable is correct, that the cable is correct. This is how you will set up the cable for the inverter. These are your cables. The Felicity battery and the Merit Sun uses RS485 communication cable. Parallel, single phase parallel. This is an example. The inverters can parallel up to 16 units. You can completely do a single phase parallel, meaning all 3 inverters supply one single phase, and you can do 3-phase parallel. I don't have an example of here in here. For the 3-phase parallel, the batteries, we will usually recommend that you put it on a battery bank, and then for equilibrium in power that each inverter draws, there's a equilibrium in power, and as well the battery cable lengths, so that you do not overuse one battery more than the other battery. For paralleling solutions, the first and the last dip switches of the inverter needs to be up. On my right hand side here is 2 SNA 5 kilowatt inverters. So you will daisy chain the parallel comms cable. the first slot to the last slot of the second inverter, and then the last slot of the first inverter to the first slot of the second inverter. If you have two inverters, both dip switches need to be up. If you have more than two inverters, 3 or 4, this is the tip that the first and the last dip switches of the first and the last inverter are up, in between, or down. The color of the dip switches, I forgot here on top. Here where the battery comes, here you'll see the red dip switches are the older version, and the blue dip switches are the newer version. Setting up your parallel for your inverters, you would go online onto your app. You would go to the single phase parallel. If it's for single phase, they will all be on the R phase. If it's for a 3-phase parallel, you would have to set them accordingly. The output phase of the inverter has to be linked to the input phase of the inverter. So if you have RST on 3 inverters, the output needs to be congruent to the input of that inverters. So if there is a mistake on the supplier side, that the 2 phases are actually 1 phase, the inverter will let you know that there's actually 2 phases that are 1 phase that's being given from the supplier. When doing the config online on the web page, some of the installers are not always aware that they need to set the inverters in parallel. You need to go online to set the inverter in parallel. You can have 2 inverters wired up in parallel, all the dip switches correct, but they're not working together in parallel. They're giving out standalone power, and sometimes, they're performing very differently to what you've expected from these 2 being in parallel. You go online, you search in your config. I will show you now on the web page. You search for your inverter, and then you set it index 1, index 2, and then this will be the result thereof. So you will have 1 and 2, and then you will have now a summation of all the values. So your solar panel summation, and your output, or your house's load, what the load requirement is. You can also toggle, you can see at the bottom exactly which inverter is doing what. For the generator remote control, the generator load input for the inverter is 8 kilowatt max. The inverter is mainly used to charge the battery. So you couple your generator to the inverter, and the inverter will use battery power to supply the load. And when the battery power is at a certain level, the inverter puts back the energy onto the battery for you to continue to use, to continue to supply the load. It does not work the solar panels and the generator does not work in the same way. Please keep in mind the solar panels and the generator on the LUXPOWER does not work in the same way. For the solar panels, you can say that the grid and the solar panels should take the load together, but on this case, the generator charges the battery, which supplies the load. Here you can charge current settings. You can set the charge current of the generator to the inverter for the battery according to how many batteries you have and the voltage of the battery and the parameters of the supplier. Generator input port and dry contacts. So you have your live and neutral of your generator coming in, and then your dry contacts. As soon as your battery gets to a certain level, the normally open contact will close, and the inverter does that automatically for you. and it will start up the generator, and then the generator will start supplying power to the inverter again. Here's more generator settings. Also, discharge settings for your batteries. Your battery warning SOC. So the generator charge type you can choose either voltage or SOC as the generator charging condition. The generator starts battery voltage or SOC charge according to the battery start voltage. So you would input it here. Whether if you're using the lead acid, you will make use of the voltage. If you're using BMS, you would make use of the SOC. And then here as well, you can your max generator input power. Excuse me. Setting up the inverter. So now this is the setup for the inverter. When setting up the inverter, as I mentioned in the beginning, you first need to set setting 2, that's your PV, your solar. Setting 3, your battery settings, set first. Those are the 2 that you first set. Checking your firmware is another tip. And setting 10 SOC must only be used for battery that has a full communication and voltage on the lead acid settings. That's with regards to charging and discharging. First working mode is the inverter use solar, battery, then grid. I think as now at this point that I'm going to also go onto the web page. Okay. So here is an example of solar to battery.
Please. And Moses, also you can also introduce yourself if any customer. Yeah. Hi.
Yes, hi. You guys able to see me?
Yeah, we can see you. We can hear you very well.
Yes. So my name is Moses Garab. I'm the sales support and technical support that is based in Namibia for NASTEC. So I'll be responsible for any technical issues and any sales issues that may arise that you guys might have. I'll be the guy to contact for Namibia and surrounding countries. Nice to meet all of you. I'll just need to follow up with Enrico, see if he's going to join us. Okay.
Yeah, thank you.
Okay, the first we're gonna try and get you an inverter that uses solar, battery, and then grid. I know many of you, as you mentioned in the beginning, you saw in Namibia, you saw off-grid. You will probably do the settings on the display on the LCD manually if you do not have internet connection. So this is how I usually search for devices using either serial number or of the inverter or serial number of the dongle. I'm going to use the serial number of the inverter. I'm actually in one of the main admin logins at the moment. Yeah, as I was saying, this is how the power gym looks like on I hope I'm still connected to you guys because I'm experiencing unstable internet connection.
Yes, we can hear you.
Thank you. Here is the power gem example. So the first setting that I want to show you. Okay, let me take you through the web page first. I think this presentation we will probably end around in the next 30 minutes or so. I'm going to take you through everything so that we don't skip anything. Here on top, you can switch between, well, on first inspection, what you see on the web page, you can switch. These buttons will give you total values. Your battery charge, took today, the total charge in overall, discharge overall.
Yeah, Enrico, can I suggest you to turn off your video? Maybe then it will not eat up the bandwidth, so it will be better quality, at least audio.
Yes, sir.
Yeah, I think it's gonna be better. Yeah, thank you.
Okay. Here we are with the feed in. Yeah, you can see how much import electricity he got in today. So he made use of sort of machine for CT clamp. So when your CT clamp is on, you make use of this function. For the SNA, you need to buy the CT clamp separate, and then overall. Also on this page, you can get battery statuses. You can do a quick charge. The quick charge will charge the battery for an hour from the grid. Here is your input and output power. Once you hover over each of these and more, you can go backwards into time to, if your client says that my inverter is tripping, you can go backwards and you can search where that has happened. This is a general over. Here you over production, you import, and you they just add this feature as well because they just only had export to grid, and then the client said, but we are using SNAs, can't export to grid, so we need the import as well, so that you use this graphs to see some versus the input on a safe.
I think Alex, we lost him again. So if you can maybe answer the question now.
Hi, Norman. Yeah. So, okay. So you mean that I can answer the following up question from Cosette, right?
Yes, please.
Yes. Look, can you just repeat the question once again?
Yeah, the main issue is, especially in Namibia, when the customer is in a remote area, no internet, when there is something wrong, we don't have access from the cloud. Normally, you know, with the LUXPOWER cloud, our team can monitor and then do the updates, upgrades, sometimes downgrades over the cloud. But when there is no internet, and we don't see any data from that unit, and it is a big problem, because then the customer complains, and then if something happens, then you don't know what's going on. Then we are relying on the WhatsApp messages and the video shoot on the WhatsApp and etc. And it would be better if we can use the mobile phone to get those logs from the device locally to the customer, and the customer device will update that logs to the cloud. Would that be a solution? Would that work that way?
Yes. Okay. The premise to get the data log from the cloud is that the inverter must be put online, and that's why I strongly recommend we should initially register the inverter and configure it to the internet, even by using a hotspot from the mobile phone. And then when we have a problem, and then we can go to the site and then connect the inverter to the hotspot, our mobile phone again, and then download the database or data log from the device. And the second way is, yes, I also discussed with Norman before. Basically, we should be able to obtain the data log from the inverter directly, but it's a very complex situation, and I also push my engineer to make our some kind of yes, a SOP to guys yes, just to instruct how to gain the data log from the inverter directly. But yes, it's not so easy. I think we need to have a lot of communication for that. Okay, we can see Enrico come back again. Yeah.
I'm back. Thank you.
Yeah,
I'm back.
Enrico.
Here you can see there's been a change since the first time I showed you this page. You can see why the change has happened. This client has an increase in the load. So the load's coming from the grid. This one is set up to use solar panels first, then battery, then grid. But because the consumptions are high, it's taking power straight from the grid, preserving the battery power. As I was taking you through the tabs, I'm going to get to the very last tab. The very last tab is the maintenance, where you do the settings. The data tab is all the charts and event histories of the device. You can see all the energy, the PV side, AC side, generator side, battery. You can toggle between each of this, and it will give you the data. You can sometimes see the battery energy in relation to in our country when there was load shedding, so power from grid. So you can see sometimes when the grid goes flat, there's no power that the grid is giving. So if you're completely off grid, you will actually see power from grid will be a flat line from start to end. Energy, that's your energy history, data history. So data history is one of those important tabs that you would go into to search for any irregularities that happened on the inverter. Here you would see the status code, giving me the status code. This is the first is the sampling of the PV, the sampling of the battery, the conversion of that into SOC. Here along you will get the bus voltage as well. Here's your bus voltages. So in some cases, the engineers in China, they also assist with interpreting the data on this data history. They help interpret the data and also to give you a better explanation of where the fault occurred and what the the data was at that point. Here's also a column that will, if you've missed a warning, here's the warning column. If you have missed a warning, it will give you in binary the warning code over here. You can export this data and also send it to the client. Local data, event history. So there's no specific local data for this one. Event history. In the event history, let me just show you something.
Enrico, could you maybe speak up a bit? The volume is a bit low on my
Sorry.
end. I think.
So in the event history, you will get your notices of all the warnings and the faults that the inverter gave you. So in this data, you'll get all the charts, all the data and event history and local data from what your inverter was doing. This will give you all that information what your inverter is doing. If I go to here and I go click on normal, here, this will become a button. This normal will become a button if there's a fault or a warning, and that button will take you to this page. It will take you to the local event history page, where you will see what happened on that specific device in the order of which it happened. The next tab is configuration. In configuration, this particular account is a Lux universal account for the technical support. But within stations, you will get your list for installer that has an installer account. Like for example, now this is a universal account. So I'll see the distributor, I see the installer, I see the end user, I see his station name, his country, and his time zones. Over here, you can create first the station end user. You can add more dongles, add dongle. So sometimes people create two end users and then they say, I've deleted the one account. Can you send it to the other account? Then what we do for installers can also do this as well. I'm skipping ahead. You unbind the dongle, and from the previous station, and then you would come to this new station that is created, and then you insert that dongle number here, say add, and now that inverter will show up to the correct station that he has on his app. Here is different bind to end user as well. So when you created the station and you have a different end user that you want to put to this station, you can do that here as well, connecting the two end users. Dongles. This is your dongle management. When you're in your installer account and you want to remove inverter, you say remove. If you want to restart the inverter, you restart. Edit. Here you can just edit the serial number, which is you want to link to a new station. That is for this. Devices. Again, refresh. If you're using a Tigo config, these are any energy management devices that you can link to the inverter. You are allowed to go ahead and do so, and then transfer data to different devices from your dongle. Depending on the type of dongle that you have, there is 4 different types of dongles, but the main dongle that we use is the BA dongles. Maintenance. So we want to get to now the maintenance overview. This is just your account. So your basic overview of the stations in your installer account or in your distributor account. This will just show you the status of each of that inverter, whether they're offline or online. For example, let me just go to this one. It has an error. I see these two are in parallel. There's two inverters and this one has an error. So as an example, take a look at what that error is. So this becomes a button now, and I can see what that error is. So it says at the event history. So for this inverter, it will now bring me up all the events. There's a fault, CAN communication fault in the parallel system. So I'm not going to fiddle with this client's. I just wanted to show you. So I want to get back to that, in station that had the solar panels. Just go to devices, search. You can search either way. His name will come up. See the load has dropped. So his draw from the grid has dropped as well. But that working mode that we spoke talking about, the first one, first use solar and battery, then grid, is in effect here. And now it's charging up that 1%. Let's go to maintenance. We did the overview. This will just be your station, your devices, factory overview, serial number, time and date. But the detailed information will be on the data page. Maintenance. So once you get to the maintenance page, firstly, just want to wait till this page loads up. Now you want to load it. Press read. You see it has a no enter button. So you wait till that is gone. Okay, there's go. This, as I said, I'm going to show you also an example of a proper installer account. So this is a universal account, which myself as a technical support assist other distributors, other installers, and other clients. So sometimes serial number. So maybe they've been at a repair center where, for example, we are a repair center here in Cape Town, and sometimes we change the main board in the inverters, and that main board comes with a serial number that's XXXXXXX. I'm not sure if many of you are in the WhatsApp groups. I'm going to send Moses links to the WhatsApp groups for you all to join the WhatsApp groups. In the WhatsApp groups, the client will usually say that he sent his unit in for repair at a specific agent. Didn't come back with a proper serial number. Then they will pop it in the group, and all of you are welcome to communicate in the group as well that he needs to have his serial number changed to the proper number. You just send us the image of the serial number and we can program it for you. Yeah. This is a lithium ion battery type. This is a drop-down menu. You can do lead acid, lithium ion, iron or battery. You see your battery, lithium ion battery compatibility list. Power rating 5 kilowatt. If I do change it to lead acid, I'm not going to set it. I'm just going to change that you can, so that you can see on the side. Then it will. So if you have 200 amp hour batteries, you will choose 200 amp hour for lead acid. If you have the smaller batteries, 50 amp or 100 amp, you'll choose, and then thereafter you'll say set model. I'll just leave this standard. There's the eco green functionality. So this means if it's lower than 60 watts, the inverter will cut off for 10 minutes. So this is some of the features. People love them. Some of the features, some people won't use them really. Battery eco. So battery eco is if your battery SOC went down to a certain level, it will start charging itself. So when the battery went down to the on-grid EOD, the AC charge and the AC charge is disabled. Once you have this feature enabled, it will automatically start charging at that point. Buzzer enable, ISO enable. This is PV ground fault circuit interrupter. Many a times the default is that this is disabled, and then if you have PV, you'd want to enable this. This depends on whether you have the earth connected to the PV or not. Input range for a parallel unit. For units in parallel, here's an example. I will change this for the client. I'll specifically change because number one, you'll see number one says UPS is grid voltage 170 to 280. This is for a single at the end of the sentence for a single inverter usage. So typically you would want to have this as for, in this case, I will set this specific one right for you. We'll give you this message set successfully. So use solar panels first, use battery second, and then grid. Here, PV off grid. This is enabled so the client can use the inverter without batteries. If he has enough solar power, he can use without batteries. That's enabled. So I think sometimes this client might disconnect his battery completely. AC first. So you want to use the grid last, entirely last. So you use the time slot 00 right through all. If you want to use the grid in a specific time, for example, from midnight to 5 o'clock. So I'm setting this, for example, now for you.
Enrico, I think
Yes.
some clients are unable to hear you. Some
Okay,
of
I'm
them
coming.
seem to be having issues with the sound.
No sounds. Here you can set the according to the time slots according to the diagram that I had the peak for the sun. Here you can set. So in South Africa we sometimes set this from midnight to 5 during the morning hours that Eskom can come in because there's no solar panels and we don't want to kill the battery, put it on its lowest, so they will let the Eskom in between midnight and 5 o'clock, and then tonight when the sun is down at 8 o'clock to 12 o'clock, Eskom will come again in. But this specific person, in this case, wants first solar, then battery, then grid. So we just make it all 00, 00 for him. Hybrid setting, PV and AC takes load jointly. This is related to this. Yeah, this on the top. If I disable this, I'm going to give you an example. Disable, all successful. And I go back. It won't even have power. I'm going to do this for 1 second as an example. I'm still waiting to accept it. So sometimes some of the settings are not accepted. You will have to refresh. I'll come back. It will probably refresh while we are speaking here during the training. To export to grid with the CT clamp, the CT clamps for the SNA is bought separately. So you need to buy that separately. And then you can export to grid. So read the data. When you come back to the pages, you need to read the data. A few seconds. I'm going to just leave this quickly for a while and then show you the result. Parallel settings, single phase parallel. If you have 3 inverters, you will go 3 phase, and then you'll set each inverter. The inverters can auto detect if, for example, here's also battery shared. So this means these batteries are on one battery bank. This is a battery below this, advanced settings. This is my battery voltage correction. So it samples the data from the battery at 52. This will be where this is sampling at this particular time about a minute ago. Charge voltage, this is my charge voltage, 57, my float voltage. This is applicable to the lead acid equalization. So do within the 30 days period, check that my batteries, charge my batteries up to the equalization voltage of 58, and it will equalize your battery at 58 volts again. And then obviously, when in your normal operation, the battery will come down from that 58 and then be within the 54 to 55 range. And then it will charge at 57 and float voltage of 54. Charging my batteries. So this is the lead acid settings on the parameters of the batteries. So I'm charging my batteries. I want to, for example, like if you're in Namibia or Saudi Arabia, you want to charge your batteries during the day. You want to, okay, I'm going to set this charge over. I might not actually change this too much. Yeah, you can set it here. Charge my battery in. This specific person is actually charging from Eskom. You set this to charge from Eskom. I would typically start with a 00 on that side. And you can set the times. So this is actually counterproductive because see, now we've set the battery charge to charge in the morning from midnight to 6 o'clock, and then from 5 o'clock to 6 o'clock. So this means this gentleman is charging from grid. He will be charging from the grid to help him be more efficient. I will actually take the initiative to do it for him. I will charge it from the sun and till about the sunshine is about till 8 o'clock in the evening. So his batteries will be getting free power. So not using it from grid. So that's what I usually typically help clients in setting a more optimized working mode. So the working modes is just a matter of optimization, how you want your system to be optimized. AC charge based on SOC or time. So the best would be SOC or time, or voltage and time if you're using lead acid. SOC and time. Start the battery voltage at 80% and end at some clients, they believe they have to cycle their batteries, and sometimes I do correct some of these things for some of the clients, because thus you could lose the battery's lifespan by not picking it sometimes up completely, because it does cycle when there's no solar panels. So the battery does cycle. Here, generator charge settings. Setting your maximum input power for your generator. Setting the charge from the SOC when the generator should kick up to start charging the battery. Generator charge via voltage when it should kick up to start the voltage. Discharge settings. Discharge settings via, this is SOC So discharge settings is at the maximum here at 110. He has 2 power gems connected. So I will leave that typically at 110. For a single, yeah, you can see for a single battery, you would take it towards the maximum kVA of that single battery. And for parallel, you can go a bit higher. Yes, parallel, so I'll leave it at that. Maximum warning, minimum warning 30%, discharge 20, cutoff at 20, on-grid EOD 90%. So when there's grid available, you will stop at 90. This battery, this is related to the power gem. Yes, and here dongle set. This will give you the dongle serial number, and you can read what cluster it comes from. Africa cluster, and here you can set different clusters. Read input intervals. Here you can restore to factory settings as well. Batch set. Not many clients will use the batch set. If you have more than a few stations that needs the same updates, you would select them. And select them, and then it would come over here. Here they now. Come over, you would set the parameters here at the bottom in a batch. You'll set them all here at the bottom, the same as you would do in a normal remote set. The way you do it on a normal remote set, you would set them in the batch, and they would all take that updates together. Set record. Here in your set record, you can see what remote set. So just select home. You'd hover over the icon, and then here it will tell you whether there's an update available or no updates. You will say click on standard update. See, here's an example of this unit was probably in for repairs now. Its serial number was not changed correctly, but they are busy updating it. Firmware version. You can get the details of the firmware version by going to the click more. You can toggle between the type of model that you have and what that version of software changes on the inverter, what it improves on the inverter. For updating your BMS of your inverter, you would go to choose file. And then input the specific battery full BMS update. So here at the moment, this is just the power gem and the Hino. For Volta and the other battery brands, you will have to contact those battery technicians, and they will assist you with that. Yes, let me go back to we had disabled the PV and AC tokes load jointly. So here we are. Let me share the other work modes quickly with you, what they look like, because this is an example of a work mode that uses AC first. Solar load during the daytime and battery backup for night. And the third one is using the inverter as purely backup battery, no panels. So I'm sure this one is very clear to understand. As direct ESCOM coming in, and when ESCOM is off or the grid is off, the battery takes over. So here's no panels involved or generator involved. Here is panels and generator involved in this one. So this one show you. So here, now I have AC coming in together. So typically you want to switch that off. Read. Because it will be very counterproductive to have solar panels with the inverter, but you did not enable the PV and AC takes the loads together. So you need to enable that. Control successful. It will then set itself again. For any of the installers that's here today with NASDAQ, my apologies, NASDAQ. I would typically open your own accounts for installations. So if you are an installer and you have to contact Moses for installer account, and you're purchasing from, for example, Moses, then he will give you a customer code. But if you're installer, you would refer you to the technical support, which that is myself, and then I'll create your installer account. So this is necessarily the information that I'll require for people that requires installer accounts. Your own information will go in here, and then I'll ask you to create a password, and thus we will create you something like this. We'll create you a customer code that you use at the end user. This is just an example of how we sometimes do it. And then we'll add, and then you will have a installer account. That is as far as the accounts that I can create for others. The distributor accounts and the other accounts, you will have to contact LUXPOWER directly. So here is a solar installer account. So what can I see in my installer account? Here's the overview.
Oh, in the battery on. Oh, then it's still offline. It's showing yes, it's offline because we are still.
Here you will see all the installations related to this installer. I also want to show you how I would, if in cases that you need help from technical support. So I took you through the tabs. You will see in your installer account, only the list here is 23 items, 23 installations for this installer account. On the overview as well, you will see 23, and it will show you which is on and off. You would have to, this is an installer account, so it's limited to being functional. It's just about being functional for the installer to do what he has to do. If there's any other changes that needs to be made, you have to contact technical support. We can support you. For example, this is a solar installation account. Through the other account, I showed you everything, what you can do on this account. Now, I just want to take you back to the maintenance account. So that account that I just looked at, so this is the account that I just looked at now on the installer account. Here you can see it was an installer account. The person it belongs to, me as a support, the location of this is the distributor and this is the installer. So CNBNB, let me give you an example. So there's no such thing as a generic distributor code. The distributor code you need to get from the distributor, or you as an end user need to get it from your installer. CNBM01. So this is also a code that many uses. So here, you see, here comes up the list of that particular, you get installer assistance. So if you want to contact Moses, or you make contact directly through the WhatsApp groups, we can assist you. I can assist you with the installer account if you are installer from and moving existing installations to your account. So I'll maybe search this username. Just refresh this whole page. Say, for example, this is a user and I need to move the account. I need to move the account. So I need to move the account from within Nastic. Say, for example, Nastic has 4 installers and one of his end users needs to go to another installer's account. Just come to management. We just find the email address, work with the email address. Tally 007. Yeah. And then I can change the cluster either from Asia to Africa or change the customer code. So I can move his customer from the Zeno Solar installer. I can move this customer to the new code, to the person the person is working with. So now I'm just going to go through the questions that you have and hopefully I can answer them. Hi there, here's a question. I have an installation where the power goes off when the battery is charged. Is the issue with the battery and the inverter? Is this inverter online at the moment? So sometimes just ensure that you need to check if it's on lead acid or lithium ion. You need to also ensure that the inverter is up to date. So it's a method of troubleshooting. Check the compatibility list. Check if the inverter is 100% up to date. And then check as well if the battery is completely up to date or if the battery doesn't have any swollen cells, because the BMSs has overprotection as well. If there's anything from Moses or the boss of Nastic,
Enrico, thank you very much. I think some of our guests left. I think now we are over 2 hours, 16 minutes. Maybe there was one guy was very keen to learn about what can cause the burns in the MOSFETs on the main board. With this particular customer, we have a couple of inverters exactly like as you mentioned, the MOSFETs completely burnt out, and we have spare parts that was in Dubai, but we shipped it to Windhoek. Now we have sufficient enough number of main boards, I think 16 plus, and all sorts of spare parts, fans, other network cards, cables, etc. in Windhoek. And so that the issue from your presentation might be the input method when they are setting up the inverter. Maybe they put they didn't put the correct PV module. Is it like a single string or a two strings, like two MPPTs? That's
Yes.
what I kind of feel like we need to focus on with that customer. And also, but it might be just a batch because it's the same, problem they had for 2 units, which is replaced under warranty with Elix's very quick approval. But of course, we want to work with our customers to not to have any issues, or once if we can prevent, it is better to prevent instead of changing and replacing. So from
Yes.
that perspective, I think Moses, you also noted this down, please. When the setting up, maybe we need to give a hand on the installer level to our customers to go through those settings, especially the PV module input is very, very, very important, that we need to make sure that it is, if it is 2 string or if it is 1 string, it has to be selected correctly. A second issue is that because these units are all in remote areas, when there is something wrong, we cannot see the logs. So we don't see the history of the unit because they are not connected to the internet. So it is very difficult. Is it like a first installation burnt out, or it was working fine for 2, 3, 4, 5, whatever, 6 months, and then something had happened, and then this, if there is any error or a physical damage in the Mediterranean, for example, Alex mentioned Lebanon. Lebanon is one of our markets that we serve with different brands. And then when there is a storm, it's very close to the Mediterranean Sea. The Lebanon is a very small country. Then there might be some, lightning strike to a communication line or a telephone line or whatever it is. And mostly houses doesn't have the surge protection. And from that surge, it may go and then jump to the network cable, and from network cable can burn a network card. These are simple things, of course, but that the setting that we need to be the installer has to set it up at the beginning, and especially with the battery, is something that we need to really focus on, to especially new customers. But one thing that is not clear to me, you mentioned that we need to connect the battery first, and then, but there is also a setting for the battery. How does it work? Like, we connect the battery to give electricity to the device to boot it up. But then same battery, we also need to tell the inverter that, there is a setting for the voltage, etc. So that, you mean that we will connect the battery in the first to the grid port just to power it up, or to the battery port? I mean, grid you cannot connect, it's 220, right?
Yes,
So,
you connect it on the battery terminals. Yes.
okay.
Just for the power. So yes, to answer your question, just to get the inverter up, you can power the inverter with a battery, and then you can start doing the settings. But the dangerous one is when you put the solar panels, because the solar panels, they immediately put over
All the
500.
all the energy, of course.
Yes.
Got it. Okay. My 2 questions. Other than that, the menus and the all remote setup is very sophisticated, very developed. We sell other brands as well, but I think this is so far the most detailed remote setting menu we see in any of the inverter, including DEA and the Solis.
Yes.
Okay.
But
Any of our customers have any
Yeah,
questions?
Enrico, I think just to add on to the 2 points that Mr. Kokyo mentioned, especially that fault 17, where there's those benchmarks on the MPPT port. I think you mentioned something about it commonly happens if the panels in the string, the voltage, the PV voltage is 500 volts, or is it more than 500 volts? And something about before, if the inverter is not properly programmed to take the PV, maybe you can just elaborate a bit on that if possible.
Yes. So the internal fault tool works
Yeah.
with both AC and DC on the buck boost system. It works with both AC and DC, and sometimes there is a surge voltage, or it's the draw. So when you put off the to grid as well, can be, so there's many points at which this happens. So you put off the grid, and then you're just using the solar, and then using the solar to charge the battery and supply the grid, and then there goes an abnormal load in the house of the person, and that abnormal load can create the fault. There can also be abnormal weather pattern on the roof, or there can be cables that is not well connected on the PV. And then obviously the other reason being, if panels were connected to the inverter and was not programmed beforehand. So the panels, also the programming, some clients could mess in the programming and then change those settings, and then immediately there's a fault that occurred. So there's a number of reasons that it can be. I hope that answered your question.
Yes, and also the other point, I think Elix answered it already. For those remote areas where we don't have network access, you mentioned that you can connect with your phone wirelessly to the dongle.
TCP
It's
local connectors.
Yeah. So in that case, so when I set it up, okay, so I set it up, I connect my phone wirelessly, or I can connect the dongle to my phone's internet connection, to my mobile hotspot, and then I do the settings. So after that, I take the inverter to now a completely remote area. There's no network access. I don't have any network on my phone. There's no Wi-Fi. So in that case, the dongle is still attached to the inverter. So in that case, it will still monitor the operation of the inverter, keep the data
Yes,
logs
that's
and everything.
correct.
Yes.
Yes.
So yeah, so for those remote areas, we can do that. We can set it up where we have internet access, leave the dongle on, set the inverter up, and then if there is a fault, once I connect to the internet again, I will still have access to all the data that is recorded during that period that it was offline.
I need to. Yes, the data will be on the inverter.
dongle.
Yes.
Oh, okay. So the moment it comes online again, I will then be able to download the logs. Okay.
Yes, sir. That's correct.
All right. Thank you.
It's my pleasure to have presented for you guys today.
Thank you so much.
I hope it was all clear. That was
Very
a
good,
pleasure.
very detailed. Thank you so much.
My pleasure. Have a great day further.
Thank you. Elix, do you have anything to add?
No, I don't have anything to add, but anyway, I still want to express my big thank you for Eric, and thank you so much for your good work and hard work for today. Yes, we make it happen. Everything is going quite very well. Thank you so much, and thank you so much for everyone who joined us in this big event. Yeah.
Thank you so much. Thank you for everybody joining.